Okay, Savannah, I hope you can see this, and this is my first attempt at this, so don't judge too harshly. I'm gonna try to focus this on the board so you can see, maybe the graphing board too, we'll see. Okay, I hope you can see this, and I hope you can zoom in if necessary. Okay, so we're on the summer calculus review packet that is yellow, and it is the one about functions rather than graphs. Yeah, go ahead.
Number 6.
Okay, this is the one you asked me about yesterday, and we got cut off or distracted or something. This particular one, number 6, you have to get really, really good at using this particular expression. As we get through chapter 1, you won't have to use it too much in chapter 1 or chapter 2 in the book, but it's chapter 2 is only 4 sections. After that, oh boy, you're gonna have to get really good at this. This thing right here in calculus is called the difference quotient, and it is super important, and it is always this. This is the difference quotient. Difference quotient. That's why they call it that, and it is only this. This is nothing else is called the difference quotient. It's pretty important, pretty big. This is what it says to do. It says evaluate this difference quotient and simplify if f of x equals, so this is the function we will consider in this. This is a general thing. This is a specific function we're going to use it on for this problem. Okay, so we've got a quadratic function here, and we're going to try to evaluate this difference quotient with this function. And before I do it, I need to remind you of a couple things so you know why I'm doing what I'm doing. So I'll come back to this in just a minute. If I ask you to, if this is the function and I ask you to find f of 2, what does that mean? What do you do? Plug 2 in for x. So it would be, without actually doing it, 2 squared minus 2 times 2, which is 0. What if I asked you to find f of negative 3/4?
Plug it in.
You plug it in, and you would get negative 3/4 squared minus 2 times negative 3/4, and then you would do the arithmetic that's around that, or have your calculator do it, right? Parentheses, whatever. You can have it evaluate that. What if I asked you to find f of x plus 3?
Plug that in.
All x's in f become x plus 3, so it would look like this. X plus 3 squared minus 2 times x plus 3, and then you would follow the rules of algebra to simplify. And your answer would have an x in it. But you'd have to simplify it. You have to FOIL this out, and you'd have to distribute this negative 2, and then combine your like terms for a final answer. Do I need to do that? You understand what's happening?
Yeah.
Then how would you find f of x plus h? Plug it in, and you would get, in for this x, you would get x plus h squared minus 2 times x plus h, and you would do the same thing to this that you did for this, but there's no numbers except for that 2. It's the same process. You would FOIL this out, you would distribute this negative 2, and then combine like terms, right? Okay. The reason I chose this one is because that's the first thing you have to do in this. And so this very first thing that you have to tackle is this expression right there. That's the first thing you write down, because you're plugging in x plus h, that thing in there, for all of the x's in f.
Oh, so we're plugging the difference quotient equation into the x squared.
No. You're taking this function, well, sort of, yeah. You're taking this function and applying this difference quotient to that particular function. And the first thing required is for you to write down an expression for f of x plus h, which means all the x's in the f we're considering, now all the x's in that function become the x plus h, just like I did right there. So the first step in this is to write down the function we're considering, replacing all of its x's with x plus h. Don't do any algebra. Don't try to do anything until you get really used to this. Don't try to do anything, but just write it down. So that's going to be squared because that x is squared there. Minus 2 times x plus h. All x's in f get replaced with x plus h. Are you following me? That is this, only this chunk right here as it applies to this function. Then it says minus f of x. Well, this is f of x. There's nothing to do here. You just have to write this down. But there's more than one term, which there usually is. you have, that negative has to apply to all of it. So you would write down minus all of f of x in parentheses and deal with the details in a minute. Just get it all down mathematically correct. So this is f of x plus h. We don't need to put all of that crap in parentheses because there's nothing out here to distribute. But we do need to put f of x in parentheses because that negative sign right there applies to all of them. Everything that is in f. You with me there? You understand the notation? And then all over h. And it is the numerator that causes you all the grief and all the stuff that you have to do next. So the h just tags along. You'll see how I'm going to bring that along. Don't forget it. It's important at the end. But that's not going to affect much until the very end. So here we go. Y'all remember how to FOIL a binomial? X squared plus 2xh plus h squared. Yeah? Y'all remember that? You better. Now we distribute the negative 2. Minus 2x minus 2h. Now we distribute the negative. Minus x squared plus 2x.
Starting with G through M as in monkey. So go take your picture thing. G through M. Auxiliary gym for pictures.
Okay. Hope you guys will figure this out when you get back. Maybe I'll send you this link. Maybe I'll send you this link. It's so blurry. You're gonna have to zoom in. Anyway, this is not completely and totally correct grammatically, I guess, mathematically, whatever. But I'm just gonna put them over h here. I realize it's not 2x over h. I'm just reminding myself that has to be brought in here in a few minutes. I'm still focused on the numerator, and I don't want to put parentheses around it all the time. You with me there? Do you understand what I'm doing? I'm just reminding myself, don't leave this off because you may forget it at the end. Okay, so now I combine like terms, and I have x squared here and, negative x squared there. Nice. Done. Now, what's happening with the polynomial? And that's what my function is a polynomial. Now I have 2xh. That's an xh term, and I don't have any other xh's, so I've got to write that down. I have an h squared term, no other h squareds. I have a negative 2x, and a positive 2x. That will always happen. The h terms will remain. The x terms will add out if you start with a polynomial. And this is now all over h. So now I'm bringing the h home here, right? Then you got to remember that if your denominator is a monomial, which it is, you can use it under each of these. So in other words, you don't have to write this step, but I'm going to write it once for you so that you know. You don't have to write this step. This is the same thing as 2xh over h. In other words, at this point right here, you can just look at that and say, oh, the h is going to get lost in that one. And then I use the h under that one. But anyway, this is the concept behind it. H squared over h plus 2h over h. And we take the h's out of each one of these. And you end up with 2x plus h plus 2. And that's the answer to this thing.
Holy crap.
Yep. You think, holy crap, wait till it's not polynomial. We'll work on it together. You'll see. I'll show you some tricks and some things, and you'll get real limber with your algebra again pretty soon. Okay, so that's only one that you've had some experience with now that you've seen. But we'll get a lot more experience, and you'll come along before I test you on it. You'll be okay. Do you have other questions, anyone? Yeah.
Number fourth one on that same section.
Oh, so section 6, number 4. Eliminate the parameter and write a rectangular equation. Is that what the one?
Mm-hmm.
Okay. All right, you guys, I've only got this camera aimed at this board, so I hope you got this written down because I'm going to erase it. Oh, yeah, sure. Just a minute, wait. Don't take a picture yet. This is just stuff to get you used to function notation again. This is the problem. It starts there. I'm using a difference quotient. It has to come up to here because I ran out of room. That's just to remind you how we do f of different things. So it doesn't belong to the problem. Okay. I can also send you this if you want at some point. All right, so I'm going to erase this now so we can talk about the next problem.
6-4.
This is part 4 of number 6. Roman 6. Okay, it says eliminate the parameter and write a rectangular equation. A rectangular equation is one that's of the form y equals something with an x in it. And what you have here is a parametric equation. We've only barely touched on this, so you may not remember it. But this thing, this x equals and this y equals together are considered as one thought, are considered a parametric equation. They're both, y is written in terms of a time element, x is written in terms of a time element, and these two together make up a whole bunch of xy points that you can plot, string together on that very grid. It's just that there's an extra parameter called, so it's a parametric equation. And our objective is to turn this parametric equation into a rectangular one, which means y equals something with an x in it. And it's really, really easy. It's just it's not something you remember, and it's not something that would occur to you to do. What we're going to do is solve one of these for t. This one, I hope, is obvious to you as an easier solving. Because if I divide both sides by 2, I get y over 2 equals t. That's a pretty easy solving. It would be, this one will require a square root. We like to dodge that bullet if we can. So now that we've solved this for t, that's what t is in terms of y. We can replace the t and x with that, and then we won't have an equation, we won't have a t in the equation at all. And so when I do that, when I make that substitution, I get x equals y over 2 squared plus 3. Okay, now I told you before that rectangular equations are of the form y equals something with an x in it. That's pretty restrictive. All a rectangular equation requires is that it have a y and an x in it and nothing else. And this does. So you could officially stop here. I think you should clean it up a little because, go ahead. I'm going to clean it up. If I wanted to write it y in terms of x, I could. It would be kind of ugly, but just watch. X equals y squared over 4 plus 3. Multiply through by 4. Start to solve for y. Continue solving for y. Any of these would be acceptable for eliminating the parameter. But this is most acceptable because we're used to seeing y by itself equals something with an x. So you should attempt to solve for y. If it gets too difficult or arduous, just stop somewhere and circle it. This is pretty ugly looking. I would really not like that. I'd like to see a little bit of your simplification skills, but
Can you bring a 2 out of the square root? Can you do that or not?
you could. You could. Yep, absolutely.
Okay,
So this would be plus or minus 2 root x minus 3. That would be fine.
okay.
That's even better, actually. It's good.
I was just confused on whether you could or not because of the negative. I couldn't remember.
Oh yeah. What this actually is, this right here is in the radical inside it before you do anything. You're taking a 4 out. This becomes a product. You're able to square root them individually. This one does, and this one doesn't. Yeah. So that's eliminating the parameter. Solve for t and replace it with something else, and do your best to solve for y. Any other questions? Yes.
Number 7, everything.
Yeah. Okay, Roman numeral number 7, everything. Yeah, that's that summation notation. There's only 2 of them, right?
Yeah.
That's summation notation, and what it means is, well, I'll write it on the board so you can see it. What's the first one? It's the sum of?
0 to 4.
Yeah, but what's the variable?
N.
N. Equals 0 to 4 of?
N squared over 2.
When the difference between this and this is less than, I would even say 8 or 9, it's easiest to just plug each one of these in. What this notation actually means is plug a 0 in for n and write down the answer. Then add. That's why this is the Greek letter capital S, because it stands for sum. Add up all of these things. And these are integers. From here up to 4. The integers from here to here, we plug them in one at a time, sticking a plus sign in between. So the next one we'll plug in is 1. 1 squared is 1, yeah?
Yeah.
Next one is 2. 4 over 2 is 2. Am I losing you at all?
No.
Next one is 3. 9 halves. And when you've plugged this one in, you're done. Plug a 4 in, that's 16 over 2 is 8. You follow? And then add those together. Now, if it goes from 0 to 100, you're gonna want some sort of other scheme. But these won't do that to you here. So it's gonna be 9 halves plus a half is 10 halves, that's 5. Plus 2 is 7, plus 8 is 15.
So is that what it means by expand?
Did it say expand?
Yes.
This is what it means by expand.
Not this one.
This is what it means by expand. This is what it means to answer this question. This is 15. But this is the expansion of it that allows you to work on it.
Shortcut for that again?
I'm sorry?
How are you supposed, what's the formula to get that without having to add up each?
You would have to be in a number theory class to know the formula. I'm not gonna teach you that. Has nothing to do with calculus.
Didn't we learn that like geometry or something? No?
Yeah, but not with 1/2 n squared. Not with a quadratic. You learned it with linear things and exponential things. Those were arithmetic and geometric sequences. This is not either one of those, and it's
Find the second one we just.
the formula for it's quite crazy.
So this is a pain in the butt.
With 5 n squared over 2.
So-
Start with 0.
This expansion, it's much easier handled that way than memorizing or learning or formulating some sort of formula. It's not worth it. So when you go to do the other one, when you go to do the other one, there's only 3 numbers, but boy, are they ugly. You remember how to make your calculator handle fractions?
What?
I'm waiting for these guys to come along. Just a second.
Plug them separately, so this one plug 0, 3,
Oh no, I wrote on there.
So on 2, you just go 1 for 3.
That makes sense.
If n equals 1.
1 and 2 and 3 is all you get. So you should get 1 plus 1/8 plus 1/27.
Doesn't get that far. That's not,
Okay,
So that's.
guys, we're looking at number 2. The number 2 on this, there's only 3 numbers, and so you should get, when you plug a 1 in, you should get 1, and then plus 1/8 plus 1/27. Do you all agree with that? The expansion isn't that bad. 1
but I.
plus 1/8 plus 1/27. If you are asked to answer this as a fraction, here's how you make your calculator do it. 1 plus parenthesis 1 divided by 8, close it, plus parenthesis 1 divided by 27. If you hit enter at that point in your calculator, it will give you a decimal. Then you go math, enter, enter, it'll give you a fraction. Which is the way you should answer it since we expanded it as a fraction. And it should be 251 over 216. Okay?
Sheesh.
So you can make your calculator do fractional arithmetic.
Have your attention the ready
Which is nice.
here, last name N through F to go to the auxiliary gym printers. N through F.
Darn.
Okay, any other questions, anyone? I bet you've forgotten how to do some things with logs and exponents.
I think I got most of these.
The only ones, let's see. I had a question.
Okay, I'm erasing this again. I can send any of you this video if you want. You can peruse it at your leisure.
Oh, 14. I have a question on 14. I don't know if that's.
The section 14?
Oh.
No, on,
Section 8?
yeah.
Yeah, there were 2.
You guys, I am really, really technologically inept. So as I ask you this, it's okay to smile and laugh inside, but do not laugh at me, okay? Apparently, the district has made it possible for all teachers to record their lectures on YouTube. So I now have a YouTube channel. I have no idea what the name of it is or how it works. Maybe it's just my name. A district did it. And that's what I'm recording this on. Can you just go onto YouTube and access my channel and find the videos that you want, or do I have to send you a link?
No, we can just, you should, if we can find your channel, then it should be good.
So I got to figure out how to find my channel, right?
It's probably just like T. Johnson. I have a channel. for
Probably something like that. I'll ask Mr. E, but I have bugged him so much in the last little while. He doesn't like to see me come into his room. You can just see him go every time I open the store, especially if I have my computer in my hand. All right. Okay, so we want to talk about section 8.
Yes.
Number
Do you remember what section 8 is on MASH?
On MASH?
Every time I say section 8, it reminds me of that. Section 8?
On MASH or MASH?
MASH. The old comedy mash about the Korean War. It means that you are taken out of the army because you're insane. If you got a section 8.
Yeah, the one guy.
Yeah, that one guy kept trying to get a section 8.
I remember one episode where he was
Klinger.
actually depressed.
His name is
He couldn't
Klinger,
get
with
out.
a big nose, anyway.
All right, that's neither here nor there. We're on section 8. It is a bit insane. Okay, so which of those numbers would you like to talk about?
3.
I mean, three's good too, I just,
say
I
we
know
should
one
start
out.
with the lowest one, which would be.
You want to go through these one at a time?
Sure.
Actually, we should number 1, because I don't think I did it.
Number 1 is already simplified. Yes, me.
So you don't have to do it.
The only thing you could write that it's equal to is to go backwards from the rationalization and write it 1 over root x. That would be fine.
But that's worse.
I know, it feels worse to us, but it is actually a little simpler. So you could just, no,
That's simplified already?
yeah, that's fine. You can leave it like that. That's neither here nor there to me. That doesn't matter. Now, how about number 2? Were y'all able to remember that about your logarithms? What is it?
3.
It's a 3. Because e is the base of the exponent, and the logarithm involved, which is in the exponent position, is also base e, and they undo each other. Just like square rooting a square or something. So the answer is 3. Y'all remember that? Does that feel right to you?
Feels great.
Okay, and now you want to talk about number 3? E to the 1 plus log x. You guys are going to be surprised how this comes out. E to the 1 plus log x. Okay, remember it's about exponents because you're not used to thinking of exponential rules in the direction we're about to use them. Can you tell me, forget that for a minute, can you tell me what x to the 3rd times x to the 7th is?
X to the 10.
It's not x to the 21st, it's x to the 10th, right? In other words, it's x to the 3 plus 7. So if you have this instead, you can come back to this sticking a times in between them. You can go use the property in reverse, do you understand? So this is the same thing as e to the 1 times e to the log x. What is e to the 1? What's e to the log x? Then the answer is ex. It's just remembering your exponential rules, but you got to think about them that they can go backwards as well. Okay? Number 4, this is just a little lesson to remember that I don't care what the base of the log is, any log of 1 is 0. Because any logarithm, without moving it around, without a transformation in it, any logarithm that you graph has one main thing. It has different shapes and different heights and different huggings of the y-axis, but they all cross at 1. So when x is 1, y is always 0, regardless of the base of the log. That's where they're all anchored right there. It's at 1, 0. Okay? So 5 is very much like number 2, only with in the opposite direction. So the answer is 7. Number 6. Good job. The answer is -1. Because 1/3 could be rewritten as 3 to the -1. And that way you have a base of a log and the base of the exponent being the same, which is 3, and the exponent is the answer, which is -1. So you have to rewrite 1/3 as 3 to the -1. Does that make sense or not? Do you want me to show you? Anybody need me to show you that? I'll do that.
Like sitting there like, just say that like this.
Yeah.
I have no idea.
I like this.
I don't think they
Beard and mustache, I was like, wow, so weird. It's like shaved.
Just put your.
I realize you haven't seen each other in 6 months, but we gotta do calculus. So. Well, this isn't even calculus yet. We gotta get going on this. Okay, so we're looking at number 6. I wanna know if you need further explanation and demonstration on why that's -1. Anybody? Yes? Because you weren't listening before. Yes, okay, that's okay. 1/3, the fraction 1/3 can be rewritten as 3 to the -1. So now you have a log base 3 and an exponent base 3. They cancel each other out and leave you with the -1 exponent. Does that make sense?
Yeah.
So what your objective there is to rewrite what you're logging so that it has a base 3. Be creative about it, and then you can use that property where they cancel each other out. Okay, others? I mean, moving on, sorry. Number 7. That's pretty bizarre, huh?
I just played.
How?
And just make.
How do you plug in your calculator? Because that's a good skill. I just want to know how you did it.
Then you go all the way to the bottom, the log base.
So log 8 divided by log a half. What'd you get? -3. Now think about this, just so that you understand why it turns out to be -3. It's the 8 that I'm concerned about, because remember that property we've been kind of honing in on? If I could rewrite 8 as 1/2 to something, then I would have what I want. I would have log base 1/2 of 1/2 to the something, and the something would be the answer. But we're going from a whole number to a fraction. We're used to taking fractions like the 1/3 and going to a whole number as a base. So I've got 8. But I want that, I'm thinking this way, I'm going to turn that 8 into 1/2 to the something. One-half is the same thing as 2 to the -1,
So I'll go to the -3.
which is, 2. If I went 2 to the -3, that would be the same thing as,
Or 1 over 8.
it would be the same thing as 1/8.
So if you would.
Sorry, let me see if I got that straight. Take this 1/2, change that to 2. That's a rewriting as 2 to the -1. So I've got 8 equals this to the something. Because I've just rewritten the 1/2.
It would be -3 because we need that to be a 3.
Yeah, we need this exponent to be a 3, so that 8 is 2 to the 3rd. So if this times this has to turn out to be 3. +3, so that can be equivalent to 8. You know what I mean? So that's the same thing as 2 to the -1 to the -3, because that product is 3, which is 8. So that's the answer to the question. Because that's the same thing as 1/2 to the -3. All of these are equivalent in these parentheses. So it's 1/2 to the -3 is the same as 8. But if you don't want to be that creative, you can just use your calculator as long as you know your change of base formula. It's great. It's great. It's not a problem. I will never take your calculators away from you.
Until we graduate.
Unless the professor at Idaho State says I must. Then I will, and I'll prepare you one.
Oh, gosh. Also,
We'll have to memorize.
They haven't gotten that far yet. They haven't done that to me yet. Okay, to do number 8, since you're mixing a natural log with a regular fraction, one's rational, one's irrational, your only option is the calculator. And the answer is -0.693.
okay.
There's no other way to do that one. Simplify it.
Is it negative? I got negative.
Yes, negative, sorry, -0.693, correct. Before we leave that one, I want you to understand this and try to remember this. I'll remind you again, but we're going to be using this idea over and over and over again. All logarithm graphs are shaped this way if you don't move them around, if you don't translate them or reflect them or anything like that. Regardless of the base, they're all shaped like this, which means that every x value strictly between 0 and 1, if you log any of these values right there, you'll always get a negative. In other words, if you ever log, and I don't care what the base of the log is, natural log, common log, base 2, I don't care what it is, if you log a fraction, the answer will always be negative.
Smaller than 1, it's negative.
Between 0 and 1, yes.
Yeah. But if
If it's greater than 1, it'll always be positive.
you can't log a negative number.
You cannot log a negative because the graph doesn't get out. There's no domain for it. You also can't log 0. You can only log positives. But if that positive number is a positive fraction, the result will be negative because your y values between here and here are all negative. See what I mean? And the closer you are to 0, the more negative it will be. Yeah? Okay, so that's the reason why that one turned out to be -0.693. It was negative for that reason. Okay, how about number 9? Anybody know what that answer is? What is it?
X to the 3rd.
X to the 3rd. And here's why. Because you have to remember this little property of exponents. I'll just do this problem as I remind you. It's the natural log of e to the, no, it was e to the 3 log x.
Yep.
Any coefficient you have in the front of a logarithm can be interpreted as an exponent on what you're logging.
Oh.
Remember that? Do you remember that? So this expression right here is the same as this one, the natural log of x cubed. This guy gets to crawl back up here onto this x. I mean, it could be written here or it could be written as an exponent of this. They're both equivalent. So if you let that come back up here, now you're in that same situation again where this cancels this and you get that. Yes.
Can we talk about why that cancels that?
Not right now, because I honestly can't remember it in my head. I've got a paper somewhere in my pre-calc book that will show you that. I will show you that, okay? Actually, it has to do with this. Y equals x to the b is the same thing as log base b of x equals y. No, other way around. Y equals x. That's not right. Oh, well, it's log
He's
base.
on the right.
Okay, wait, I got to put the b here and the x here. I want this to be considered a constant. These are usually variables. This is a constant. That's correct now. Right?
Yeah.
Okay, so if I have e to the natural log of x, and I want that to be x, I have this situation right here. Let's say that was equal to y, just so that I've got an equation that I can use this on. Okay, so now change this thing for me, understanding that we're in this situation right here, change it to this.
So it would be log base e.
Okay, that's all right, we can do that. So that this is demonstratable for all logs.
Okay, yeah. Of y equals the natural log of x.
So this is the same thing as natural log y, right?
Can I have your attention already for
And
junior?
the
That's
natural log
writing
is
A through
natural
F to go.
Right, that means the y equals x.
Okay.
Juniors, A through F.
That help at all, Sam?
Yeah, that helps.
Okay, okay, we're moving on. Let's do number 10. Was that a struggle for you?
Yeah.
This has nothing to do with logs though, right? Just exponents. Okay, then I'm gonna erase the board and start again. First thing I always do when I have a fraction involving exponents is I put everything where the exponent will be positive. If it's negative, if your exponent is negative in the denominator, put it in the numerator, it'll be positive. If it's negative in the numerator, put it in the denominator, it'll be positive. So on this one right here, I'm going to rearrange things as 4 and x, they stay in the numerator. And the y to the negative 2 goes downstairs and becomes y squared. The 12 stays down here. The x to the negative 1/3 comes up here as a 1/3. And y to the 5th comes up and becomes a positive y to the 5th. Are we okay on that? Yeah? Okay. What's the exponent on this x? 1. And what do we do with exponents when we multiply? You add them. So this would be x to the 4/3. Are you all good at adding 1 to 1/3 and getting 4/3? Okay. The 5th. All I did is multiply in that step. I suppose we could have done much more than that, but now I'm going to start canceling what I can now that I've got my stuff together here. 4 cancels with a 12 for a 3, and 2 of these y's cancel for 3 of these. So I end up with x to the 4/3, y to the 3rd over 3. And that's it. That's all you can do. So move your exponents to where they will be positive. Apply your rules of exponents if necessary, and start canceling. This step right here can be a bit dangerous, a bit like walking through a swamp, because it gets so messy, it's hard to see what you have left over. So be careful with your canceling and scrubbing out and stuff like that. The next one, anybody know the answer to number 11?
9.
Did you get that with your calculator?
No.
Here's that's good, I'm glad. What you have to remember is that we're doing 27 to the 2/3, and the 3 is the index on the radical. So it's really the cube root of 27, whatever that is, squared, which is 9. Or in other words, There are 3 3s in 27. You are asked to take 2 and multiply. 2 of the 3 3s. 2/3. Okay? All right, on the next one, number 12, anybody have an answer?
28 to the 13/6.
That's correct.
Yeah, the 28.
20A to the 13/6.
That's what I got.
Cool. So do we need to discuss that one?
Yeah.
Can we walk through it? I don't
Okay.
remember how I did it.
The 5 times the 4 is just exactly what you think it would be, which is 20. And then on the exponents, you have to add 2/3 to 3/2. And if you do that with your calculator, because I don't want to do the arithmetic, you get 13/6.
So it's 20.
20, because 5 and 4 behave like they always have in a multiplication problem. They're just the big numbers, coefficients. And then the exponents on the little guys on the A, they have to add together since you multiply. And it adds up to 13/6. We all right on 13? I mean, what'd you get for 13?
8A to the 5/2.
Perfect.
5 halves?
Yep.
Crap. About 15 halves.
8.
Three more.
3. 3 times 5 is 15, but 3 times 2 is 6, and 15 over 6 is 5/2. Yeah, you gotta reduce the fraction. When you multiply fractions, which is what you're required to do, you multiply the tops and you multiply the bottoms. Sorry? Because it's 4 to the 3/2 also, which means to square root 4 and take 3 of them. Does that make sense? 2 times 2 times 2?
Yeah.
Square root of 4 is 2, and you're supposed to take 3 and multiply them together, that gives you 8.
And what was the fraction? 8 what?
5/2. 8 to the 5/2. And then number 14, you guys have very limited experience with factorials, right? Okay. So this is gonna take a little bit of explanation before you can understand it, so just hang in here with me. Do you know what factorial means?
I have an idea.
Yeah, 5 factorial does not mean 5. That's not what it means.
5 means
5 factorial means this. 5 times 4 times 3 times 2 times 1, and 5 factorial is just a number, whatever this product is. It's 20 times 6, which is 120. That is 5 factorial. And so 10 factorial would be a heck of a lot bigger. As a matter of fact, there is nothing in numeracy. There's nothing that is more powerful, not even powers of 10, that's more powerful than a factorial. As a matter of fact, your calculator will handle things up to times 10 to the 99th. It says overflow after this. Just so you understand the idea behind a number this size, 10 to the 99th. Scientists have determined and agreed upon the fact that there are probably only 10 to the 72nd atoms in the universe. Not the solar system, the universe. 10 to the 72. This is a much larger number than that.
What?
This is 10 to the 17th universes. 10 to the 17th universes has this many.
Wow.
This is an enormous number.
That's a big number.
So your calculator, the guys that designed your calculator decided not to let it go higher than times 10 to the 99th. Once it gets to a 3-digit number here, it says overflow in your calculator. Get this. 70 factorial will get you an overflow. Just 70. That's not that big of a number. If you want to check that out, go to, it's in your probability menu, your factorial key. And so you would type in 70, like this, if you want to check out the overflow, what it looks like. 70, and then you go to math, over to probability, and in that list, about number 5, I think somewhere like that, you'll see a factorial.
Oh,
Grab that and hit enter, and it will type this, and then you hit enter, and it will say overflow.
so if we go 69.
Yeah, try 69, that's the limit. Try 69 factorial. And you should get something to the 98th, I think.
Yeah.
10 to the 98th.
1.7. 69.999.
Times 10 to the 98th.
69.
Factorials, just as a thing to remember in your mind, factorials are more powerful than any other mathematical thing that you can do to numbers for making large numbers. Factorials are phenomenal.
Entirely and just figure out 69 factorial.
Yeah, that was
She must have to work this out. Most probably.
Okay, so listen up. So I wanna know if you understand this. If I asked you to expand this a little ways, if I said expand n factorial, that would be n times the number just below n, which is this, times the number just below that, which is n minus 2 now. You understand that this is a way to write it if it's n factorial? Down to 1. Does that make sense? Yeah? Then how would you write n plus 2 factorial? What would you start with?
And then plus
N plus 2.
and plus 2.
You start with what you're factorializing, and then what's 1 less than this? And then, and what's 1 less than that?
And
And what's 1 less than that? Oh,
minus 1.
could I write this like this? Because it would just continue with all the other numbers down. I could just put factorial behind that one, couldn't I? Just like I could have up here said 5 factorial is 5 times 4 times 3 factorial. I could, it's the same thing. It just means we expanded it down to 3, now it's gonna go on. Yeah? Do you understand that? Okay, so to do number 14, we could write this. 3 times n plus 1 factorial. I'm going to put a bracket around here. No, n plus 1 times n times all this other stuff down here. But I'm going to stop right here. I'm just going to stop it right there. Do you understand I could write n plus 1 factorial this way? Why would I do that? Because these all are multiplied. If I put down here the denominator, which is 5n factorial, it doesn't matter what this number is. All of these will cancel. Does that make any sense to you?
Is that kind of?
Okay, let me do it with numbers. Maybe I can drive the point home. I'll leave this here, but I'm going to show you what would happen if I had 7 factorial over 5 times 6 factorial. That would be the same thing as the difference between this n plus 1, this is n. Yeah, you see that? And so I could write this as 3 times 7 times 6 factorial, which would be 6 times 5 times 4 times 3 times 2 times 1, right? Over 5 times 6 times 5 times 4 times 3 times 2 times 1. So do you see that all of these are going to get, that is 6 factorial got lost, so I end up with 21/5. You see that? Up here, I end up with, now that we understand that this factorial, whatever, all these numbers that tack down to here, and all these ones that track down to here, they're all the same, they get all canceled out, so that gets lost, we end up with 3n plus 3 over 5. All done.
What?
Crazy, huh?
That's unfair.
It feels unfair, but it goes down to nice things pretty quick. So just to make sure you got this idea down, this concept, can you simplify this for me? 2 times, well, I'm going to put parentheses, n plus 3 factorial over 4, no, 5, the fraction we do, right reduction now, n plus 1 factorial. Do you know how to tackle this? Okay. Then let me show you, and then I'll give you another one until you got it down. Yes, what would you do?
Wouldn't you just multiply n plus 3 with n plus 2 and everything else would be canceled, and then you multiply that by the 2 over 5?
That's what he's suggesting we do, because we stop here, because this will all cancel. So this factorial here is this one times the 1 less than that times this n plus 1, which is 1 less than that, which is what matches down here. And this would be 5 over n plus 1 factorial. This all gets gone. Do you see what I'm saying? You FOIL this out, distribute the 2, that'll be n squared plus 5n plus 6 times 2, which is n squared plus 10n plus 12 over 5. Do you see that? Not really, yes.
Wait, so why do you stop at n plus one? Why is that your lowest value?
Because that's what's in the denominator, and I know that this n plus 1 factorial, which is what remains, will cancel with this one.
Oh, so no matter how much further you go, it'll all cancel.
Right, right. That was evident over here with the 7 and the 6 factorial. You see what I mean?
Yeah.
So we stop wherever this is, because when it becomes that, all the numbers that encompass this and this are all gonna cancel, and I'm left with this over 5. You see what I mean?
Yeah.
Okay, so now, try this one. Everybody try this one and see if you can do it.
Teachers, can I have your attention, please? I need the juniors, G through M. Thank you.
That thank you sounded like the intercom version on Polar Express. No, it's the with like Scrooge's nephews, that Christmas movie where they go to the North Pole. That's what that sounded like.
Okay.
So by the way,
I always associate phrases like that with movies too. That sounded just like Endo. What it actually says in the book is, you will not. You cannot, not you shall not. Peter Jackson changed a lot of stuff, but shall not sounds a lot better. It sounds a lot more wizardly.
You cannot pass.
You will, or you will not. You shall not sounds much more.
You shall not go here.
Anybody have an answer? Anybody know how to begin?
you gotta
You go all the way up to 1 on the bottom, right?
no, you go
Or
down.
Do you go down on the top?
You go down on the top because n plus 1 is greater than n minus 1.
So n plus 1 and n minus 1. N minus
Lose
1
it. So you end up with n times n plus 1 times 2.
spread everything out. You know, I didn't actually do it, but
Okay,
yeah,
you could.
do something.
You could. You understand the concept then, because you just explained it to me. So what do you get? 3n squared plus 3n over 7. Think you follow this? I just find this very, very interesting. This will not show up in calculus. But it's a good thing to know about factorials, because it will show up on your lives again. It will. You will take statistics, and you will be very glad that you've had this at least one time.
So if the larger factorial were on the bottom,
Then you would just have the polynomial on the bottom. Yep, same thing would happen if your bigger one were on the bottom. It's just, would end up with the polynomial part of it on the bottom instead of the top, which would be fine.
Great, we had like a student teacher come in my first class and try to teach us these.
In what?
We had a student teacher come and try to teach us these in 6th grade.
Oh, yeah?
That didn't work.
I bet you weren't ready to absorb it like you are now.
Oh, no.
Yeah, factorials in 6th grade.
I tried like, but like just how to do it with like addition. Can you do factorials with addition? Yeah, how? Try teaching us that.
I remember
It's
learning
like 5
Mrs.
plus
Bond,
1.
Mrs. Bond was in 6th grade.
But it was super confusing.
Well, the reason why this will come up in your lives, they're going to show you a formula for figuring out combinations and permutations of possibilities for happening. And a combination of n choose r is n factorial over r factorial and minus r factorial. And so you will need to have some experience with these numbers.
So isn't it like stuff like if you had 20 action figures and you had a display shelf that'll hold 4 of them, how many combinations do you have?
Like that?
Oh,
Yes.
is this like the
You
combination?
have 20 things, how many ways? This tells you how many ways there are to choose 4 of them. That would be 20 factorial, which, as you understand about the size of factorials, is a huge number.
Over 4.
Divided by 4 factorial, and then
But it's great because you're calculating.
16 factorial.
Why
Did you see that?
16?
Because 20 minus 4 is 16. It's the big one minus the little one factorial.
Why do you
What about-
put that as a denominator?
What?
Why do you put that as a denominator?
when you take statistics, they'll develop the formula. I'm saying you need to have this kind of experience here to handle the reduction of this.
Does NPR have that same sort of?
No, NPR is this. N factorial over N minus R factorial.
That's like. Why do you get rid of the R?
I'm teaching
Well, what's
statistics.
the NPR?
One of these days I'll answer that question for
What
you.
are the NPR and NCR?
It's the permeation combination.
This is 20 action figures, this is 4 of them, and they're all have equal value. This is 10 horses in a race. How many ways can 3 of them come in first, second, and third? That's when you have to put it first, second, and third.
The order matters.
The order matters.
Yes, sir.
It's kind of like choosing a presidency in church. If that were random, but it never is, it's always inspiration. But if it were random, and you had seven priests in a quorum, and you wanted to choose a president, vice president,
Counselor?
counselor, and a second counselor, and then it mattered, then I could choose, if I chose you 3 as the ones I want to choose from, there are still 6 ways to make a presidency out of it.
Oh, shut.
But if I wanted to just choose a committee, I just wanted to choose 3 to serve on the Bishop's Youth Council, and it didn't matter which one you guys are, there's only one way to choose you 3. But there are 6 ways to choose you 3 and make a presidency.
First, second,
So,
third.
permutate, this one is a larger number. No, this one's a, no.
Counselor.
No, because we're priests, so first is this.
I think I got these backwards, because this one has,
I feel like.
this one's a larger number, this one's correct, because you divide by one factor. Yeah, you have to divide by one.
So what would you use? You have 16 people in a room, how many, and they all shake hands, how many handshakes?
Yeah, I don't know.
How many times?
That's again, probability and stats. Okay, listen up. Shh. If you understand what you know about factorials now, you could write this one as, you could write this one as 20 times 19 times 18 times 17 times 16 factorial, so that you could lose the big one, over 4 times 3 times 2 times 1
Times 16.
times 16 factorial. That's gone. And now you can take the 4 into the 20, the 3 into the 18, that's about it. Well,
Yeah,
To
they're
the
both
19.
fine. Both fine.
what, oh yeah, take the 2 into the 6. I could have taken that 6 into that. 2 into the 6 gives you 3. So you get 5 times 19 times 3 times 17. What is that? I don't know. But it's a lot smaller problem than doing all of this junk if you understand the canceling principle.
48, 45.
Okay? So what we're saying is that there's 4,845 ways to choose 4 of those action figures out of the 20. There's 4,845 groups of 4,
And is that
different groups of 4.
groups of 4 in a specific order?
No.
So it's just-
Specific order would be 20 permute.
Oh.
And there's more ways to do that.
There's more ways to do that.
So if we.
Because every time you 4, there are,
Sorry,
I can't remember, I think
I'm sorry.
it's not 16, but there are several ways to group those 4 in order. So every one of these groups of 4 actually add purpose and order to them, rank them, adds that many, this times that many more. That's the reason why we don't have the 4 factor.
So all it is it's 24 times. bigger
Yeah,
than
20,
that number.
yeah, it's 24 times this would tell you how many ways to put them in order.
Oh, God.
Because every group of 4 can be rearranged 20 ways. That's the reason why this does not have this in it.
Oh.
I really don't want to get hung up on that, but I love factorials and probability and stuff like it's fun. It's fun stuff. Okay, so we are done with section 8. Finally. Are there other sections of this we need to address tomorrow? Because I want to quit here and figure out how to take this thing and give it to Savannah. So I got to take, so we're done for now. Bring these back. We will continue working on these until you have every question answered and every concept in your brain, at least for the moment I'm explaining.
I only have like 5 more questions.
Oh, can I get
Isaac doing that defensive calculus, right?
No. Yes, it was. He was one of them.
So can I get one for the green sheet if I did?
Oh, yeah.
Sorry?